All right, functions, this is the warm-up that we started with. It's got a couple skills. Something I want to highlight is this one and this one. You would have to get both of these right on the test to get this skill. This is its own skill. And then you would need to get both of these correct to get that skill. This would be its own skill, and this would be its own skill. So I'm just kind of giving you a quick preview to what you can expect to see on the assessment, minus the stuff we haven't learned yet. Go ahead and hit pause, and I'd like you to do this on your own. Okay, so go ahead and check your answers. So for number 1, you should have gotten the cube root of 64 is 4 times -1 is -4. This one, if you rewrite in exponential form, remember the power goes up, the roots go down. So it'd be x to the 9/6, which simplifies to 3/2. So something that I saw a lot yesterday, especially through the formative, was we weren't simplifying our fractions. So if you can simplify, especially when the directions say to simplify, always simplify. This one's a little tricky. We have to remember that anything to an even power is going to be a positive number. So it's always going to end up being a negative times a negative. That equals a positive. So we need to remember that we have to do the negative absolute value of x to the 12/4. Again, I can simplify that. The absolute value of negative y is positive y cubed. Then we multiply that answer by -1, and that's how we get that. This one, the 1/3 only belongs to the w, and the 1/4 belongs to the 81. So we have 81 to the 1, or the 81 and the w to the 1/3. So we have 81 to the 1/4. W to the 1/3 to the 1/4, which gives us the 4th root of 81. The 4th root of 81 is 3, so that's going to go on the outside. And then we have a power to a power, which means we multiply. So we get 1 times 1 is 1, 3 times 4 is 12, which is w to the 1/12, which when we rewrite it in radical form is the 12th root of w. This one we had to rewrite in exponential form, so we have -3q power on the top, 9/45. That can be simplified, so we end up with -3q to the 1/5. This was the problem in the formative, so I went ahead and did it. Not every class got to it, so I thought I would cover it. If you want, actually, I'll go to the next slide, and I'll let you look at the formative so that you can do it on your own if you missed it. So what I did is I went ahead and figured out what my denominator was so that I could start combining like terms. That's what we're doing. We're just doing it with division. So you end up with y to the 1/2, or I'm sorry, y squared to the 1/2, which is 2/1 times 1/2, which gives you 2/2, which is y to the first power. Where's my mouse? Which is right here, y to the first power. And then the z was 1, so 1 times 1/2 is 1/2. So then I went ahead, a couple students did a different way. They moved all the negatives down and then combined like terms. I went ahead and just did it the same way and dealt with the negatives at the end. So what I did was I brought this one up. So I did -1/4 from the numerator minus the 1, which is 4/4. You have to have common denominators. So then I end up with -1 minus 4, which is -5/4. And then I did the same thing for the z. So I did -1/4 minus 2/4. Again, I had to come up with a common denominator. So then I get -3/4, and then when you get them positive, so those were all in the numerator, when you move them to the denominator, they become positive, so you get 1/y to the 5/4, z to the 3/4. Okay, this one I just rewrote on the inside out, so I got x to the 1/2, to the 1/4, to the 1/3, and that's a power to a power to a power, which means 1 times 1 times 1 is 1, 2 times 4 is 8 times 3 is 24, so x to the 1/24. All right. If you have any questions, please let me know. But here is the formative that we did a couple days ago. My face is in the way, so I'm going to move me. Okay, so these were the questions. These were non-calculator part. This you could use a calculator for. This you could use. This you could use. And these ones. If you have any questions on this, please come. But number 6, I would definitely star. Before you start number 6, you need to figure out what this is, and then start your distributing. All right, so go ahead and try that. Go ahead and hit pause. And then I'm going to go to the next thing. Okay, we are starting a new thing. We're solving equations with radicals. We're going to solve a radical equation by using the power rule. We're going to use that a lot in all the different levels. Today we're going to start with the progressing level. We're going to solve radical equations that require additional steps. So that would be meeting. And then we're going to solve radical equations with indexes greater than 2. So like the cube root, the 8th root, the 9th root, the 20th root. It doesn't matter. We'll know how to do it because the power rule doesn't change. And we may use the power rule to solve for a formula. I don't know that we'll get to it, but I always hope for it. Okay, so the power rule says that if you take both sides of an equation raised to the same power, then the answer to that equation is going to be the same answer as the new one. So that's all that says. Here's what I do want you to write down. Check your answers. So just like in the last unit, where we could end up with a number that doesn't make sense in the denominator, which in that unit would be 0, for us, we need to know what numbers make sense with the different radicals that we have. We need to know that if we have an odd index, a negative solution is okay. But if we have an even index, then having that underneath. So what I showed students in class was, what if I have the square root of -4? Why isn't my pen working? There we go, -4. If we have that, we could say, oh, there's no real solution because the square root of -4 is imaginary. So that would be an extraneous solution. Or we can have different other circumstances. So make sure you write that down, start in your notes. Check your work. Make sure your answers work. All right, so the first thing we're going to do is write this down. This says solve. So that's different than simplify. That's different than what we've been doing this whole time. We've been just simplifying. Another thing that should clue us in that it's different, we've got to equal to something. Before, if we look here, nothing was equal to anything. It's just a problem. Just a problem. So now we're going to be like this. This is just a problem. So we're just been simplifying this whole time. Now we're solving. We've got that equal sign. Now we've got equations. Before we had expressions. Okay. So after you write this down, the first thing we want to do is we got to break out that 5x plus 1. The best way to do that is to undo that radical. It's all by itself, so we can square both sides. When we square both sides, that undoes the radical. And we end up with 5x plus 1 equals 16. And now this is just a regular linear equation that you probably have been doing since 6th grade. So we're going to subtract 1 from both sides, divide by 5, and we get x is equal to 3. But we need to check our work. We've got to plug it in. So everywhere we see an x, we're going to replace it with a 3. So that unit 2 that we did in functions is now coming into play. Now we know what x is. Let's figure out what our y is. So we get 5 times 3 plus 1 equals 4. The square root is 16. Does that equal 4? Yes, it does. Then our answer is going to be 3. In the homework, it'll ask you what is the solution set. It's just ask you for the answer. Make sure you check it. Okay, here are the steps that you're going to want to take when you're solving an equation with radicals. The first thing you need to do is isolate that radical. That means if you're multiplying something by it, you got to get that away. If you're adding or subtracting something to it, got to get it away. So anything that's near that radical needs to be moved away. Then you apply the power rule. Once you have, so like in this one, notice that the square root is already by itself. So if this said the square root of 5 plus 1 minus 4 equals 0, then we would need to move that 4 to the other side. But we didn't have to do that on this one, but that's what that's saying. All right, then you want to apply the power rule. That's where you raise it to whatever the index is, the same exact thing, the power of the index. So if the index is 20, raise it to the 20th power, and that will undo it. And then you solve the resulting equation. Now this can be tricky. So in progressing and meeting, you probably won't have to repeat steps 1 and 2. In advanced, you will. You will be repeating it at least once. So it's going to be multi-stepped. That last one we did is a really good example of progressing. It's because it's something you did last year. But we will get into more complicated cases and we're going to solve. And then you have to check your answers. That is step 4 on the test. I'm expecting to see that you've checked your answers. Okay, so now let's try this one. Go ahead and hit pause and try to solve this one on your own. Something that I would say this unit does a really good job of is now we know all these rules. We've got all these steps. We've got all this information. But now we're going to use it to help us like figure out that we can use our brains to help us shortcut things. We know what steps. So while I agree with most of you, we're not going to use this math in everyday are your everyday life. You're not going to use upper level math. I use it, but I'm a math teacher. But we are going to be using those logical things. There are times in your life where you're going to be solving a problem and you're going to get an answer that does not make sense for that type of problem. Or you're going to do all this extra work and realize looking back, shoot, I could have stopped sooner and I didn't have to go through all of that. I'm not going to make that mistake again. So this is where we're starting to train our brain. So while I am teaching you math and the content I love, but I'm trying to also get you guys to start doing those problem solving things. So that's where this unit does a really good job of that. And the next unit that we do also. So now you probably, after listening to me, have written down this problem. The first thing we need to do is isolate that square root. We've got to get the square root of 5x plus 3 by itself. So I'm going to subtract 2 from both sides. Now you can subtract 2 from both sides, right? And we're going to, let's see if I can find my pen. There it is. Okay, so then we want to square both sides, right? If I could. There we go. Okay, so then I get 5x plus 3 is equal to 4. Subtract 3. I get 5x is equal to, 1. Divide by 5. I get x. I get x. Okay, hold on. It's going to hold on. Okay, so I tried to change the battery, but I got x is equal to 1/5. We get the square root. 5 times 1/5 is 1. So the square root of 1 plus 3 plus 2 is equal to 0. We get the square root of 4. Oh my gosh, so this is not working. Okay, the square root of 4 is 2. 2 plus 2 does not equal 0. So that does not work. But what if I told you you could have stopped that problem solving before? So, okay, I'm going to have to... So we got no real solution to this, but what we could have done is stop that process a little bit further, or a little bit sooner. We didn't have to go through all of it. So one of the things that we would have noticed is that we have a square root is equal to a negative number. Can a square root ever equal a negative number? No. Since it can't, it has no solution. So even if we did all the work, we proved that there is no solution. So the solution set is called the null set. So in your homework, you may have to use that symbol. But that's something that we could have just stopped right there. We didn't have to do all that extra work. So again, this is one of those times where there's nothing wrong with doing all that work. It's going to tell us that we would have been able to figure out sooner. And with experience and with practice, you will see that sooner. So hopefully you start to get it. All right, if you have any questions, please come to class with them. You should be able to now do, I think it's up to number 10 on part 3. All right, I will be posting another video for advanced. I'll try to get it done before Tuesday when I cover it. Thank you guys. Have a great day.